Hi everyone, today I have a very special guest on the channel. Hi Ted. So Ted is a PhD student at Okinawa and he also a creator of the YouTube channel called Synergies. I'll leave a link here, and if you're up for intellectual challenge, check it out.
Describing my major at OIST, the Okinawa Institute of Science and Technology, is a little difficult. I often just say it's machine learning, but to be more precise, I'm in the cognitive neurorobotics lab, where we want to make robots a bit more like the folks, thinking like the people think. I think I've always been interested in math and science, and I remember the first time I saw Google's Deep Dream. Google Deep Dream images they were fascinating, but I think nowadays they'd be considered very primitive. But I remember the first time I saw those, I wanted to get computers generating art like that. And so I think I've come a ways in a different direction, but I think that's where it started.
Topic of a merger between quantum computing and robotics, which probably mainly will be focused on quantum computing and machine learning. So quantum machine learning. Both fields are still evolving. Quantum computing is not as old as artificial intelligence. The first idea of utilizing these quantum properties was proposed in 1982 by physicist Richard Feynman. He's actually one of my favorite physicists. And since then, it's been kind of a roller coaster. In 2016, the max qubits we could have in one machine was 6. And today, in 2024, IBM introduced quantum computer with 433 qubits, and they're promising 1,386 qubits in 2025. Quantum computers use quantum mechanics. And in classical computers, we use bits, which is 0 and 1. In quantum computing, there's quantum bits. That's a general term for any particles that display quantum properties, which can be electrons or superconducting qubits, can be photons. Some companies try to use ions. In order for those particles to display quantum properties, they actually have to be in a very special conditions, almost absolute zero temperature. But what are those special properties? And one of those properties is called superposition. And superposition is a state of quantum particle where it exists in this probabilistic position, where it's not 0 or 1, it's a probabilistic combination of collapsing to 0 and 1. It can be 20% 0 and 80% 1. So that allows to store more information in one quantum bit, because we can store in one qubit more information than we can store in one bit. As you pile up those qubits, the computational abilities of that machine increases exponentially, but so is noise and error. So that's one of the challenges in quantum computing. We're having issues, first of all, developing algorithms for noise correction, and second of all, having hardware that we will be less noise prone and error prone. Having those states let these machines explore many possibilities simultaneously, enabling complex computations that we can perform in parallel. The main players in the The main players in the industry, IBM, Google, Rigetti, there's D-Wave, but D-Wave mostly utilizes what's called quantum annealing, and that's good for finding minimum of the function. I think through finding the lowest energy state of the system, but they don't utilize any other quantum properties. Therefore, a lot of criticism was around that they're not real quantum computing, but they're actually selling it commercially.
Just to have a measure to compare it, about 1,000 qubits is what we were promised next year. How many bits is that? How many qubits to the bit, if there's an answer to that?
It's a good question. I don't think there's real comparison, just because one bit can store two states, one qubit can store combination of those. I'd say it's like exponential, but I don't really think that's really equivalent because algorithms are different.
I'm imagining that if qubits are sort of continuous, I'm sure there are a lot of different ways to measure it.
Plus, on top of the fact, there's stuff like entanglement. Yeah, so we were talking about quantum walk. So that a paper I looked at offered this idea that by utilizing principles of superposition and entanglement, the quantum random walk can be more efficient for search strategies for robots in complex environments. What kind of complex environments?
Well, I think I already mentioned situations which have continuous actions, but an environment can also have continuous states. So I just said in Markov chains, I think the states are discrete. If we imagine just walking from one place to another, there's so many states in between that. I think Archimedes, that's supposed to be racing a turtle, is actually always going to be in front because there's that continuous action of Archimedes making it to the turtle. So the reality is really complicated, and we could simplify it by pretending it's discrete, but there's so many continuous things that things can be between.
One thing I forgot, so there was this one idea that you can use quantum mechanics to teach robots to navigate in the state of uncertainty. What would that mean to teach robots about uncertainty?
I am so glad you brought that up because I think that's Friston's free energy principle, which is sort of what I'm trying to get a PhD in. The Friston's free energy principle is all about uncertainty. And when you understand some parts of the environment but don't understand other parts of the environment, then you might keep going to those parts of the environment in a way which is based on Bayesian statistics.
That is something I really want to discuss more in depth, but I guess we can leave it for our next conversation. I think there's plenty. There's plenty more to discuss, but for now, actually, we're going to move on to Ted's topic, which is a continuation of this topic and splitting it between two channels for you guys, so you can join whichever topic you want. See you in the next video.
Bye.
But what does it all mean? Yeah.
I wash myself every day, but then stop. Am I even clean? Does my tongue make me clean? How does the tongue work? Perhaps I am truly unclean. It's possible. And yet I wash myself anyway. How long have I been sitting here? How long? What is time?